Many of you who have been practicing domain-driven design would be able to identify these two terms pretty well: bounded context and ubiquitous language. But for those who are new and uninitiated, these concepts can be understood more in detail from the very famously known Blue Book of Domain-Driven Design by Eric Vence, or if it seems to be too lengthy for you, you can learn these concepts from a Green Book by Von Vernon, known as Domain-Driven Design Distilled. But for the sake of our continuing our story and conversation here, I'll give a brief about what exactly is a bounded context and what is an ubiquitous language. A bounded context is a contextual boundary within which a software model is designed for a specific domain. So all the software model operations that happens within that contextual boundary is very specific to that domain. And the communication between the models within that boundary is in a language known as ubiquitous language, or more commonly known as domain-specific language. So you basically use a language which is very specific to that domain whenever you are doing some interactions between different software models within that fixed domain contextual boundary. So that's a high-level introduction as to what exactly is a bounded context and a contextual boundary. So now that we know that, let's get back to our story. Now, every time I got a domain-related query, I would go to that same SME and get it cleared. It happened at a very higher frequency than I imagined. Over a period of time, I had created a huge set of notes with clarifications and domain details, which had a lot of concepts and a lot of domain information in it. Everything was good so far. I also tried to replicate all of those concepts and information domain details I understood in my test scripts and test code so that my test cases would reflect exactly what the subject matter expert expected the test to perform. Now, no matter what the outside world says, a test automation effort is a software development work. It takes the same amount of discipline to write a test code that a development code needs. And we developers love rules. When we start writing code, we follow all the rules, such as don't repeat yourself, solid principles, you ain't gonna need it, or more commonly known as YAGNI, and of course the famous page object pattern, which is followed in the test automation world. What does all these following rules do to your test suite or test scripts? It leads to abstraction. Abstraction is good code-wise, but what about the domain details? They often get lost in our design model. This is one of the areas where behavior-driven development comes to our rescue. Before we get into the principles of BDD and try to understand what exactly BDD means at a very high level, there is a software development paradigm which is a predecessor to BDD known as language-oriented programming. This was put forth in 1994 by a gentleman named Martin Ward. The research paper by Ward, which gives information about the language-oriented programming and all the details, are easily available when you do a Google search. You can find the PDF online and you can read more in detail about it. But here is a brief information as to what exactly it means. Instead of solving a problem in general purpose programming language, the developers can create a domain-specific language and solve the same problem in that language first. This sounds similar to what we just discussed, right? The concept of bounded context and ubiquitous language. Yeah, I mean, exactly. It's similar. It's the same thing. It's the same ideology here, presented in a different manner. So this is present in the 1994 paper where Ward explains as to what exactly is a language-oriented programming and what is a domain-specific language and what are the benefits of language-oriented programming. The benefits are explained in more detail in the paper, but for our conversation purpose, let me give a brief overview as to what the benefits are. Some of the benefits are separation of concerns, which typically means a domain-specific language. That is, you are separating the domain details and domain information from the implementation programming code or the programming language details when you're writing your language-oriented programming code. So that's one of the benefit. The other benefit is something called as high development productivity. So high development productivity is nothing but you write code only specific to the domain needed for the boundary that you're working in. So if you have created a domain-specific language for a specific software model domain that you're working on, You write code only needed by that domain, and you do not write anything that is not needed. Now this also sounds similar, doesn't it? Yeah, this is similar to Yagni, which we saw earlier. You ain't going to need it. So you don't code anything which you don't need it. You code only what is needed, as simple as that. The next benefit, as specified by Ward in the paper, is highly maintainable design. This can be connected to the concept of refactoring. So refactoring is a very well-known concept. So highly maintainable design leads to easier refactoring of code. So that's pretty much what the benefit is, which has been explained in Ward's paper. The other three benefits which is explained are highly portable design, opportunities for reuse, and user enhanceable system. All three of them are similar to the solid principles concept. So if you know what a solid principle concept is, all these three concepts are similar to it. If you don't know more about solid principles, then you can, if you want to know more about it, then you can go ahead and look up Uncle Bob, and you can find out all of his books. One of the most famous book is the Clean Code book, which you can refer to find out all the solid principles and how useful it is when you go ahead and write any code. Now, okay, so in order to keep the domain details from the SME alive in the project, back to our story. In order to keep it alive in the project, I started exploring these BDD concepts. The moment I started Googling about BDD, the search results were filled with Cucumber testing and Gherkin feature files. If we don't settle for these search results and explore more, it will dawn upon us that BDD is not Cucumber. Cucumber is only used in the automate phase of BDD, whereas BDD has two more important phases, namely discover and formulate. So if you are a tester crunching out feature files in isolation and typing them to your tying them with your test scripts and test codes in the form of your Cucumber step definition or implementation, then you cannot claim you're doing BDD. You're only doing the automate phase of BDD, and even that is not being rightly done because you are the one crunching the feature files, and that's not the right thing to do. So first and the foremost thing, BDD is not a framework, but a process. It involves not only the tester, but also the developers, business, and other members of the team, usually referred to as the three amigos. In the discover phase, these cross-functional members gather for a meeting and begin with a simple process of gathering your requirements. This is the discover phase. It could be, you could use any simple process to do the discover phase. One of the well-known processes using something called as example mapping. So in case of example mapping, you go ahead and take a story, and then you write some rules that are connected to that story, and then you go ahead and find out examples for the rules. You do not have to follow the exact order. So you could also be working such that you could come up with examples and then connect it back to a rule. But it's much more easier to get a rule and then connect it back to an example. Or connected to an example. There are many other processes of doing the discovery phase of BDD. Some of them are one of the other well-known processes known as specification by example. You could also take a look at it. That's also a process. So in this process, cross-functional people come together, take stories, and then make more concrete requirements out of those stories using one of these processes. So once this is done, then that's when you go ahead and do the formulate phase. But before you go to the formulate phase, something in the discover phase or something in the example mapping which helped us was substituting the rules in the example mapping with heuristics. So we roughly call it as example heuristic mapping. The modified version is what we treat it as, because we still are following the same example rules mapping, but then instead of rule, we are doing the example heuristic mapping here. Now, what exactly is a heuristic? Heuristics are simple rules we develop based on our experiences. They are a set of cognitive tools. That is, they are a tool which helps us to take decisions. It could be based on our experiences, or it could be based on a set of biases that we have in our mind, or based on certain patterns that we've observed earlier. So there are many different types of heuristics out there, but some of the two of the most well-known heuristics are availability heuristic and then representativeness heuristic. To know more about these two heuristics, you can read one of the best book out there on this topic. It's Thinking Fast and Slow by the Nobel Prize winner, Daniel Kahneman. if you go ahead and read his book, you can understand more in detail as to what exactly is a heuristic and what are the main differences between different types of heuristics and how you can apply it when you're doing your example mapping. But just for the sake of our conversation again, I'll just give a brief ideology as to what exactly is availability heuristic and what is the representativeness heuristic. Availability heuristics are basically nothing but based on the examples we know from the occurrence of something. So if you want to know the frequency of occurrence of a certain scenario, then it's an easier way to arrive at that frequency by thinking about examples which you can connect to that scenario and then try to find out the number of examples and get the frequency. That's much more easier than directly approaching the question as how frequently does a scenario happen. So that's what in a brief ideology is what availability heuristic is about. The next type of heuristic that is well known is representativeness heuristics. This is more about your preconceived notion based on your previous experiences. While dealing with this heuristic, there is a huge possibility that you could have cognitive bias. Now, that's completely a different psychological topic, which I'm not going to get into detail in this presentation. But cognitive bias is nothing but you have some bias or you have some preconceived thoughts in your mind which is hindering thinking out of the box. So basically, this type of heuristic helps you to have thoughts and ideas and based on what you've experienced before regarding the same topic. So yeah, these are the two well-known heuristics out there, but there are many more other types which you can read more in the book, Thinking Fast and Slow. Applying this heuristic in place of the rule helped us a lot because in case of a rule, when we say something is a rule, we are kind of fixing or sticking to that ideology, and that restricts our mind from thinking. But when we replace that rule with a heuristic, we are open to more different ways of thinking. And that helps us to come up with more different types of examples when we are doing the example mapping. So now that once we are done with the discovery phase and we have our example and heuristics ready for all of our stories, we can then go to the formulate phase. Now, formulate phase is the phase where we start writing our feature files. Yes, the same feature files which is very popular because of Cucumber or any other Gherkin language, which is what is used to write the feature file. So now, when you start writing the feature file, before we even get into writing the feature file and try to understand Gherkin language and the feature file in a more brief manner at a high level, let's look at a logic which was put forth in 1969 by Hoare, by a person known as Hoare, and this logic is known as Hoare logic. So Hoare logic or Hoare theory is pretty well known. If you're a student of computer science, you would have definitely come across Hoare logic and Hoare axioms. These are used to basically evaluate how a code and then find out the quality of a code. So basically, you can evaluate the strength or the weakness of a code using Hoare logic. So there are many axioms which come into picture, which was put forth by Hoare in this Hoare axioms, Hoare logic. So before we get into the axioms of the logic, one thing which is important for the Hoare logic is the Hoare triples. So the Hoare triples are the one that you're seeing on the screen right now. So they are the first curly braces with P is known as the precondition, and then the C is known as the command, and then the Q seen between the curly brackets is known as the post condition. Doesn't this look similar to something that you know already if you have been following BDD? You're right. This is similar to the given, when, then concept of the Gherkin language. Your precondition is nothing but given. Your statement or the command that you're going to run is the when, and then your post condition is nothing but your then from the Gherkin language. So now that we have established the connection between the Hoare logic and the Gherkin language, given, when, then, the Gherkin language which is used to write the feature file, can we actually apply the rules or the Hoare axioms that is used to evaluate the code to evaluate our feature files? I mean, why not? I mean, if we can use that to evaluate the code, can we think about using the same axioms or same rules to evaluate the strength and weakness of our feature file? Let's go ahead and try that. So that's exactly what we did. So we went ahead and tried to evaluate the quality of a feature file using Hoare logic. But before we get into the topic, we need to understand as to why do we need to evaluate the quality of a feature file? Why would we want to do something like that? Simple reason. The quality of our feature files should be good enough if we want the quality of our test code to be good. It's like if you are constructing a building, you want the foundation to be strong enough for the building to be strong. If your foundation is weak, the building will crash. We may spend a lot of time to ensure the quality of our test code by building fancy automation frameworks and using all cool new libraries out there. But if we don't spend time to ensure the quality of our scenarios in the feature files, then we cannot expect good ROI from our test automation. So that's the basic reason or the basic need as to why you need to evaluate the quality of your feature file along with evaluating the quality of your test script code. So let's begin with our Hoare axioms and try to apply it to our feature files. So here are the 6 well-known Hoare axioms which are generally applied to evaluate the programming code. But let's see how we can apply it to evaluate our feature files. The first axiom we will look at is known as consequence rule or consequence axiom. Don't worry about the squiggly math expressions we are seeing here. Don't be intimidated by it. They are only for the representation purpose, and we are more interested about the idea behind these axioms than to solve these math. So here we see a precondition, say a p is greater than 10, and then we run a command, and then we see a post condition q, right? So the consequence holds true for the precondition greater than 20 as well. So that's what the Hoare axiom says, that if we say that p is greater than 10, and then you run a particular command and you are getting a post condition, then if p is greater than 20, the same post condition should be achieved if you run the same command. So how do we apply this to our feature file world? So let's see. In our feature file world, when we are writing our scenario, if we have a scenario where we know the final consequence, which is the then part of our given when then, if we know the final consequence very well, we should spend time in finding all other scenarios which will lead to the same final consequence. Keeping this axiom in mind will help us to not miss such scenarios. So let's take an example. If we have an application where we reach a specific page of the application from a menu option, we also need to ensure to see if there are other different ways to reach the same page and have scenarios for the same. So that's pretty much how you can apply the consequence rule or consequence axiom to ensure the quality of your feature file. Now let's look at the next axiom from Hoare. It's called the assignment rule or assignment axiom. In the math expression, we see that for x to be 9, the precondition is that y should be 9, right? That's when the assignment of x equals to y will lead to the post condition of x to be 9. In our feature file world, this translates to, if we know the end result of a scenario, find all the preconditions and then find the reverse scenarios for those. That is, see if there are scenarios where if the end result of a scenario is executed, then does it lead back to the precondition? Little bit confusing, isn't it? But let's take an example to understand it in more detail. If we have an application where we choose seats and book a movie ticket, and the expected outcome is for the ticket to be added to the shopping cart, we also need to have a scenario where given we have tickets added to the shopping cart, the seats are already assigned to the tickets and not available to be added by any other user or the same user. Is that clear? That example makes it more clear, right? So yeah, this will help you to ensure that you have such scenarios available in your feature file and ensures the quality of your feature file and the quality of the scenarios that you are writing in your feature file. Now let's look at the next rule or next axiom. The next rule is the sequence rule. In our feature file world, this simply means to ensure the sequence of events which leads to a specific post condition are properly represented. This is nothing but effective use of the AND keyword in your feature file in your Gherkin language, as well as whether we are effectively reusing the scenarios by using the background keyword. So it's just to ensure that all your feature files, if you have scenarios where you want to ensure the sequence of events happening correctly, that you are using the proper and then the background keywords when and where needed, and you are taking into account all the intermediate scenarios when you are evaluating a scenario, and writing a scenario for a feature file. So that's pretty much what a sequence rule is. The next rule is called as the conditional axiom or conditional rule. Here, we need to ensure that we take into account scenarios where the state of the application does not change for both positive and negative commands. What do you mean by state doesn't change for positive or negative command? The state has to change for something, right? But there are certain scenarios in the application where the state may not change for both positive as well as negative commands. Let's take an example of that. If you take an example of a video streaming site, say YouTube, the trending video section of the website should be available to the user irrespective of if they are signed in, that is a positive scenario, or if they are sign in failed, that is a negative scenario. So a sign in being successful or a sign in failing should not impact the trending video section of that specific user, because that video should be available irrespective of whether you are signed in or not. So your feature file should ensure that they have such scenarios which follow these conditional axiom from Hoare rule. This will aid you or help you to write more effective feature files, effective scenarios in feature file. The next axiom is the iteration rule. Here we ensure that the examples we use in our feature file to carry out our parameterized testing, examples is basically the example section of your feature file in the Gherkin language, where we provide our parameters using pipes. We just have to ensure that those examples that we provide in this parameter also include negative test data parameters that do not alter the state of the application. So it's just as simple as adding different types of parameters, but also ensuring that there are parameters which do not alter the state of the application, and we ensure that there are scenarios which check those, which confirms that the state of the application remains the same as that of the precondition when these non-altering parameters are supplied to our test cases. Does that make sense? So now the sixth axiom is called the empty axiom or skip axiom. I did not have a slide for that because I am skipping that axiom, because that axiom is very straightforward and simple. All that it means is that if no action takes place on an application, the application remains the same as before. This is implicitly covered in all of our feature files, right? Because when you do the given step, the step definition or the implementation we do for the given step automatically takes care of this particular axiom. That it ensures that if no action, that's what the given is. That given is when you check that everything that is in the given, the precondition is satisfied. So when you're checking for the precondition to be satisfied, you're also confirming that if no action is taking place in the particular in the specific application, then no result should be, nothing should happen. The state of the application should remain the same. So since this is an implicit check, I kind of skipped this slide. But it's something that is good to keep in mind when you're writing your scenarios in the feature file. So those were some of the Hoare axioms which can be used as an aid when we are building scenarios in our feature file to ensure quality of our feature file. Now, there is also one more model from the aviation world on which the whole title of this whole talk is, right? So this model is known as V-Speeds. In aviation, speeds are derived from data obtained by aircraft designers and manufacturers during flight testing for aircraft type certification testing. Now, that's a completely different type of testing. That's not the testing that we do, right? But still, the V-Speeds model, how can we use that model to ensure the quality or aid in ensuring the quality of our feature file? We will look at just 3 well-known V-Speeds and how we can apply that concepts to our feature file to ensure the quality of our feature file. So the first V-Speed that we will look at is called as the rotation speed. Rotation speed is the speed at which the rotation of aircraft should be initiated for takeoff. Now, how can we apply this concept to quality of our feature file? This is very specific to an aircraft, you say, right? But we can apply it, we can aid it, we can use it as an aid when we build our feature file. We can measure the percentage of coverage of a feature by the scenarios present in the feature file. And if it meets the minimum percentage we have defined based on our context of the application, we can measure the completeness of the feature file. So this will help you to measure the completeness of a feature file. So that was a lot of terms and a little bit confusing, right? So let's break it down. So when writing scenarios in a feature file, if we can track the percentage of feature covered by all the scenarios in the feature file, we can measure it against the overall specified rotation percentage for the project. say for example 60%. And if the feature file meets the VR percentage for the project, we can mark that feature as complete, else it will be marked as incomplete. Say a red flag or something which just says that this feature needs more work. Make sense? So this helps you to ensure whether a feature is complete based on the coverage percentage provided by the scenarios that is returned within the feature. It is to be noticed that all these judgments of whether the scenarios are covering the feature is something which a human being does, and those are the steps which cannot, those are the phases of testing which cannot be automated, which needs a manual tester to go ahead and give those judgmental percentages to the coverage of scenarios for a feature file. The next speed we will look at is known as the stalling speed. This is the minimum speed at which the plane is controllable. Now for us, if a feature file has not been catching issues or has not been changed for a predefined interval, then it is not a controllable feature file. So we can mark it as a red flag for stalling speed, VS. Just note that these speed indicators or the V-speed indicators that we are using here, may it be rotation speed or stalling speed, are only aids and not any hard fast rules. It is perfectly fine for a feature file to have failed the stalling speed. That is, it's perfectly fine for a feature file to not have caught any issues or not changed for a long time within the specified interval that we have predefined. These indicators are only an aid which helps us to check and revisit to confirm that the feature file is in a good shape or has a good kind of scenarios in it. Okay, so the next speed we will look at is the maneuvering speed. Highest safe airspeed to control abrupt disruption. So that's a very short and sweet definition of what basically a maneuvering speed is. In our case, if the frequency of change for a feature file is very high, then that particular feature file needs to be revisited with the entire team in the example mapping board. So the example heuristic mapping board that we saw earlier. So if at all we see a feature file in which there is a high percentage of change that is happening within a specified short period of interval, then something is wrong with that feature file. If the scenarios keep changing in a feature file, then we need to go back to the drawing board. That is, we need to go back to our example mapping board, get the entire three amigos into a room and figure out as to what is going on with that particular feature file. Something is wrong with the feature. The requirements are not as concrete or the requirements are not as definitive as we assumed it during the discover phase. So that's something, that's a speed or that's a monitoring speed which you can use to understand the quality of your feature file. Again, it is to be noted that both the Hoare axiom or the feature for the feature files as well as the V speeds are only aids which serve the purpose of indicators to ensure the quality of feature files and should not be treated as rules written in stone. So if you treat them as rules in stone, or if you treat them as hard fast rules, then they are not going to give you the same benefits that you get when you just treat them as aids which will help you to find out as to whether your feature files are in good shape and quality.